for people that want to rewatch the event. So this will be also shared. The same is also true for additional mails and events that might occur in the future. For example, other IoT development webinars and webinars in the context of IoT and analytics. So welcome to our webinar. My name is Murat Baran. I'm a solution engineer at Software AG. So I'm usually in the pre-sales appointments together with customers in context of ADAMOS or in more general in context of IoT and analytics. And today I want to guide you through the new OEE application on the stack of the Cumulocity IoT stack. So showing you the application and how this application can bring you some benefits. So we will go briefly through 4 basic chapters. So first of all, at the very beginning, I will just demonstrate you how the OEE is a KPI that is measured live from various machines or devices, and how this can be used to achieve visualization or in dashboarding, such that this KPI can be shown and visualized for shop floors, for example, or shop floor managers that want to see how their machines or their shops or lines behave. Second, we are going to talk about how different OEE profiles can be configured. So I mean, since OEE is depends on how customers define their different KPIs, it is highly necessary that every end customer can basically generate his own OEE calculation logic, and we will show you how the Cumulocity OEE app handles this in a manner that everybody can configure his OEE calculations themselves. We will then go into the idea of how OEE data can basically be used together with other data, so such as using the data for streaming analytics, for example, but also how the data can be used together with other integration systems or with other systems integrated, such as an SAP system or a planning tool, to give it even more insights about my production processes or my customers. And last but not least, from a perspective of somebody who's selling machines or devices, we will show how this application can be largely and scalable, distributed, and even managed, such that the whole thing as a solution becomes a powerful solution that can be sold on stack of the Cumulocity. So let's go into the first chapter, which is the OEE application, the idea of the measurement of OEE KPIs in stream, so to say, so automatically calculated OEE factor KPIs, and also how the visualization takes place. The thing with OEE, so the overall equipment efficiency, is that it's basically the de facto standard KPI in manufacturing industry, right? So I mean, all the customers that are producing something needs to somehow collect data in order to continuously improve their processes. So what they usually do is, in order to get unbiased data, they do manually recordings. They have indigenous processes like Excel sheets or paper. You can see that here in the screenshot. So there's a lot of effort included in collecting data that can be used to somehow calculate OEE KPIs. So the OEE application here on the Cumulocity basically should help and will help to aggregate OEE KPIs for machines, lines, areas, sites, and will also deliver root cause analysis and visualizations of different machines for the shop floor, such that the manually collection and also the acquiring process of the OEE data is less manual effort. Let's have a look on that in a little demo. So what I'm going to show you is how this OEE data is visualized in the OEE app on the Cumulocity IoT stack. I will also show you how there are different hierarchy levels for lines, sites, and machines, for example, how the different dashboards looks like, and how you can do the very first root cause analysis in order to find out where you basically lose performance or why it is that your KPI drops. So let's move to the OEE application. Just in general, the OEE application is one application here inside the stack of the Cumulocity IoT. And this OEE application opens up an overview. So this is something that a manager or somebody that is working on the shop floor or close to the machine lines is overviewing, so watching what is basically happening at his machine or device park. And what you see here is that my machine park here consists of two sites. So me personally sitting in Darmstadt. So this is why I created the site Darmstadt, but also colleagues of mine who are sitting, which are sitting in Hamburg. So I created basically two sites here. So my machine park, which has currently an OEE factor of 57, and I'm targeting 65, as you can see here. So this is why this is indicated red, with a trend that is rising. So I see that the OEE is slightly going higher. And I also see that my sites do have KPIs, such as 61 here and 52 there. And the machine park is just the aggregation of those two sites. So I get an overall view about my whole machine park, but also how the different sites behave. If I drop in a little bit, so let's move a little bit into Darmstadt, I see that my site Darmstadt consists of two areas, for example. So those are two different buildings. And I see that the areas behave different. So I have an OEE factor for my area Darmstadt U9, which is the building I'm located actually, but also for the U12, which is another building, where you can see that there the performance is less good. And again, the site aggregation consists of the areas below that site. If I go even deeper, I will see that the Darmstadt U9 basically consists of two machines. So one machine that is performing not so good, you can see that here, and one machine that is performing pretty good, so even better than I expected or targeted. And from that point of view, I can now deep dive into those different machines, because I basically want to see how the machines behave or act in reality. And for that, I do have two different dashboard views. And I want to show you that. So just open them here in another tab. The first dashboard is called an Enden board, and this is for the context of continuous improvement, the possibility to visualize close to the machine, so on shop floor level, how the different KPIs, so availability, performance, and quality, how those are currently. So I can, for example, allow here the possibility to update this screen every 4 hours, for example, or per shift or per day. And thus I can visualize transparent how the different machine behaves on shop floor level in order to improve certain effects. The other dashboard is more detailed. So here I do see a machine dashboard where I can pick up my time frame. So I want to see, for example, the OEE data of the last week or the last day or even the last month. I can give up a resolution, so in which time frame I want to analyze or deep dive into the OEE KPIs. I do see the OEE and also the KPIs of availability, performance, and quality, and I can dive into that in terms of I can check the history, how the different KPIs behaved in the last couple of hours, days, and weeks, in order to see, for example, if there was a machine breakdown. So you can see that little sign here, whether this indicates that the OEE factor was going down or up, and which of the KPIs is the reason for that. Which brings us to the next functionality here, where the loss ranking based on Pareto is shown here, that on this particular machine, I see a large amount of loss in the performance. So if I'm looking for my 6 failure analysis, so which is the reason why my machine has not the OEE I'm targeting, then I would see here that I have to improve the performance and that the quality and availability are less responsible for the drop in OEE here. So just to sum that a little bit up, so I mean, without OEE, from our experience, is that there's a lot of manual effort in generating the OEE data. So people walking around on shop floors, they do have multiple Excel sheets and paper stuff where they're basically recording all the values. Maybe they do have systems, but then in the systems they are starting off manually batching them through other systems, or somehow aligning the different data from various systems, since there's not really a standard for that. And then there's, of course, manual effort included in how to do the data analysis. So usually customers then start developing Excel macros or visualization macros in BI tools. But there's a lot of manual effort involved. And with the OEE application, our idea here is that the generation of OEE data is based on status messages and measurements of the different machines and devices. And this done automatically. I will show you in a minute how this is configured. And then you can use out of the box tools for the data analysis, where you basically just sit on the data and create the dashboard and views you want to look at. Which brings us to the next chapter. So meaning I already said that the idea of configuration and configuring different OEE profiles is very interesting. So what we know is that the idea of how an OEE is basically calculated differs from customer to customer, right? So I mean, there the definition whether adjustment is loss or not, whether setup is loss or not, what is a minor stoppage, what are quality defects and what not. This is per customer. So every customer, even sometimes every site, decided differently on how they behave and how they put those losses into the pillars. So it's kind of like a company policy, I would call that. So everybody's deciding how the OEE is calculated. The same is true about the targets. So I mean, there are customers targeting just 90%, so others just 30%. So it depends highly on the company. It depends on highly what they are producing and what part are they producing on which type of machine. So there is no general assumption that 100% is the key to target on OEE. This highly depends on the company. And also the data collection is not standardized across shop floors. So it depends highly on what systems are used there. This can be even vary within the same company across shop floors. So there's really not a standardized way on how to calculate the data, how to do the calculation, and also what to target. So the idea of the Cumulocity OEE app is here to deliver a generic approach where we enable end customers with a non-code environment to configure how the OEE application should be, how the OEE KPI should be calculated by the application. And this is what I'm going to show you. So we will basically deep dive into a profile creation for a machine. So we will do the matching of the calculation for the availability. We will do the same for the performance. And we will also do the same for the quality, such that you get a feeling on how generic this approach actually is. And thus, we'll see then on basis of any information that comes from machines, devices, or other systems, you can basically calculate the OEE KPI. So let's jump into the tenant here again. I already opened a profile here, which is called webinar demo. So this is the profile here. And basically the wizard, when you start creating a new profile, it guides you through the different steps of creating this profile, which is then the basis for the calculation of the OEE. So besides the name and the pickup of a machine, so I already skipped that, it asks you what types of pieces are you producing. So whether you're only creating some bricks on the machine, and it of course asks you how much of these bricks are you producing per hour, for example. But you could also connect it to a production plan where you have different parts, depending on some numbers, you are producing in what manner, at what time, for example. The interesting part is here now the matching. And I will delete the old matching so that we can build it up by its own. So basically here is all the magic for the generalization. As I already said, every machine is sending different signals and you get different types of informations from machines or systems that should now be somehow used for OEE calculation. So let's do it on the production time, right? So production time means how much of the time I'm actually available and producing. We can define a calculation. And in here, in the wizard, I can add calculation rules. So if I click on that, it basically asks me now, how should I, as the platform, personally know that this is now the availability of the machine or not the availability of the machine? The simulator that is running here in the background is basically sending a heartbeat. So we see that quite often out in the field, that machines are sending status signals once in a while, so every second, every 10 seconds, every minute. And here now, I'm using, for example, this events, so this event information from PLC side as heartbeat, that this is used for the calculation of the times that are productive. So if I select here, it asks me what is the provided information. So is it an event? So we say an event is something that is not a measurement, so meaning not temperature, not nothing that is number based. So for example, it could be door closed, door opened, I changed the program, whatever. Is it an alarm? So I don't know, machine is in breakdown, for example. So some machines are only informing the customers or the users that the machine is not producing. Or is it a measurement, for example? I have produced 1000 seconds now, where the value is basically important for me. And in here, in this demo, the value of the heartbeat is basically in an event. So the machine itself is sending the heartbeat every once in a second, such that I pick my machine. And now I'm asking here which type of events are coming from to the platform. And you see here that currently this machine is sending an availability event. And I can check on that. Then I can check this event and I can see, okay, there is something that is called a status. And now I will basically just add that this status needs to be equal to a string, and the string needs to be up. So you see, I already made some assumptions based on the simulator that is running, but out in the field, this might be totally different. So maybe there the event is not called status, but I don't know, like current status or whatever. You can basically, from a UI perspective, pick that up here. Maybe the string is not up, but it's a bool or a number that says 1 or 0. Or maybe it is not up and you want to do it vice versa. So with all these operations inside this calculation rule editor, you can basically build up the logic for how the actual production time should be calculated. So whenever now an event comes with up and with up and with up, the times in between are used to calculate the production time. And as soon as there's an event where the status is not up, then this is time that is unproductive and will be used for the loss. Let's do it on the actual production amount as well, so that you get a better feeling on how generic this actually works. Again, we are defining a calculation. I can add a calculation rule. And in this example, the calculator is sending, I produced a piece, I produced a piece, I produced a piece. So every time the machine is producing something, it sends an event for that. So I'm basically counting events, right? So I count the events from my machine. And now, of course, the wizard asks me, yeah, which event should it be? And you see it already here from the naming. There is an event that is called piece produced. So now I'm counting all the events with the information included piece produced. And this indicates me how much I did produce. And we can do it for quality as well. We add a calculation rule. We count the events. Because we see already there is an event that calls piece produced, piece OK, I'm sorry. So the number of piece OK events is basically the number of pieces that were produced with a good quality. And with that, I do now have all the matchings. I can define short stops, for example, or my goals, and then we'll see, for example, which I'm targeting. And if I save that, I'm done with the configuration. And this will then lead to the dashboards you have previously seen in the chapter before. So before going to the next chapter, let's just summarize what we have seen. Basically, the idea is here that end customers do have various machines with various types of signals. So some machines are sending start signals, some machines are sending stop signals, some machines are just sending heartbeats. Others are telling you how much they produced, others how much they had and scrap. So in order to achieve generating an OEE that is also diverse depending on how the company wants to calculate the OEE. The OEE app itself allows you with this wizard and the calculation rule editor that you can basically sit on every information that is coming to the platform and create in a non-code environment, so basically just configuration, how the OEE should be calculated for each particular machine, for each particular work pieces. Which brings us to the next topic. So now I do have the OEE data, which is nice if I want to visualize it, but there's more actually. So I mean, currently the OEE data is only used for the visualization and for the analysis in history. But this is due to the manual recording process, right? So I mean, since it takes so much time to collect the data manually, match it manually, visualize it, then already days and hours are left where you have to probably I don't know, work against a trend or something like this. So there's basically not the possibility yet to combine it with other informations of other systems, combined with alarmings and such, that you cannot basically get the full potential of OEE. So the combination of OEE and other data, such as IoT, but other systems like ERP, CRM, or MES systems, can increase the transparency on what is producing and give you much more insights about the processes, such that it can be more efficient and you can continuously improve. So this is what we are going to show you. We will show you how you can basically use the OEE data to create a powerful alarming. So meaning we will sit on an OEE calculation and want to be notified when some values differ too much over a certain time frame, such that somebody gets informed. And we will also enrich the OEE data from other systems. So in this example, we will do it with the SAP system, but I will also show you how it could be done more generic with other systems such as MES or planning systems, such that it gets much more information in and thus much more transparency on the underlying processes. So let's move to the analytics builder. So this is my possibility to create powerful KPI calculation or alarmings. So what I do have here on the left side are called function blocks. So I'm working here in my workbench here, so my dashboard, and I have the possibility to use inputs, which are my machines. And I also do have outputs, which can be my machines, but can also be, I don't know, certain trigger events such as SMS or email. It could also be, I don't know, like flashlights or traffic lights, whatever you want to. And I also do have function blocks that have some logic, so meaning calculating a difference, calculating another KPI, doing some rounding, lookup, whatever. So there are many function blocks included in here. And I basically work here that I move function blocks into my workbench here in the center, which guides me through the process such that I'm just combining different function blocks. So here now I'm subscribing to measurement inputs from a machine. So here it's the availability machine over the last hour. and I'm using this information and I'm putting it into the gradient block. So I want to check the gradient of this measurement over the last, I don't know, let's say 10 hours, because I can calculate that easy. So every 10 hours, the gradient, so over a time period of 10 hours, the gradient is built up for the availability. And this value will inject it into the threshold block, and the threshold block is exactly doing what it says. It's triggering if a certain threshold is exceeded. So for example, if I say the gradient is, I don't know, larger than, I don't know, it's going below -2, for example, and I'm breaching this limit, then I want to send a SMS to somebody that is responsible with a certain text, check platform. Stay in English. Let's do it that way, right? And with that, I can even extend this this workflow that is triggered here. So I could, for example, apply and counter how often this happened, right? So I could include that in the text that this has happened over the last, I don't know, last 2 weeks, several times on the particular machine. I can build up standard deviations, right? So I don't know, to do more statistics. I can even start to do more complex flow manipulations with latches and combiners. So this gives you a very nice and easy non-coding environment where you can basically build up even complex rules, such that at the end people are getting alarmed if something happens. People are getting alarmed if something intend to happen. If you are working with gradients and trends, for example, but also gives you the possibility to create certain new KPIs that your company is, for example, doing. You could basically do that, for example, with the expression block, where you can basically build up, and here you can open the help, where you can basically do any mathematical calculation in this expression block, for example. So that is part one, as I already mentioned. So the analytics builder guides you through these processes where you can build up new alarms and routes. Another one is, as I already said, the possibility on creating, just give it a thinking second, just give it the possibility to create workflows for or in between various systems. So this is in our product that is called webmethods.io. And so here I do have the possibilities to trigger also these workflows. So you see I do also have kind of a workbench here in the center. In this applications that I do have the connectors or the function blocks here on the right. So what I can do is I can pick the various systems that are already provided by our solution here. So for example, an SAP, but also like, I don't know, like all the Office stuff that is included. Same is true for Teams. So there are various connectors that can be used, and I can move those connectors again here into my workbench and start creating a flow, right? So for example, I'm picking up the latest OEE, and if this OEE, so I can also apply conditions to those arrows. So only do this if this condition is fulfilled, for example, and then extract me data from my SAP system. So what part are you producing currently? You can store that in an additional database, for example, so a data lake system maybe. And you can also open maybe a ticket for the factory of the machine if the machine is in a major breakdown for several hours because of performance lost, for example. And with this, you can combine many systems, such as an SAP in here, to gain more insights about your production process. So what are you producing, for example, when the OEE goes down? Is there maybe a trend? So you could analyze this then on the database storage, so like a data lake system. And you can do this with various connectors, which you can also extend. So it is always the possibility to create generic connectors here based on Node.js, such that you can connect other systems that you have out in the field or you want to connect. just to sum up this a little bit. So I mean, the OEE app itself is not just for visualizing the OEE factor. It basically gives you the possibility to configure how the OEE KPI is calculated. It gives you also the possibility to visualize that. But as the OEE app itself is built up on the stack of the Cumulocity natively, you can use all the other functionalities on basis of the Cumulocity platform, meaning everything that is combined with device management or machine management, for example. Same is true for data and analytics. You have seen that in the analytics builder where we created some alarming rules, but same for integration and API, which I showed you. So such that you can combine it with other systems, such that the OEE app itself is one major benefit on the platform, but together with other informations inside the platform and functionalities, this gives a much bigger picture and thus brings much more value to the end customer. And here, together with all the deployment options on cloud, edge, or also on-premise or hybrid, you do have the possibility to use the platform at that point on that environment or infrastructure you want to use it. And the OEE app, just to mention that at that point, is here just one example on how a solution could look like, right? So, I mean, we're basically here in the solution approach where we are already delivering one major benefit for end customers, which machine builders, for example, can sell to their end customers in order to have a benefit on the platform. Yeah, that was the wrong direction. I'm sorry. Which brings us now also to the last to the last point, to have this scalable and distributable and manageable. So I mean, what I just showed you, the OEE app is one beneficial application and customers might want to have, right? And I mean, it mostly addresses, so the stack of the Cumulocity mostly addresses machine builders, for example, where they can basically sell the OEE application on the stack of the platform. And for those customers, it needs to be efficient to distribute and scale the application, right? So they do not want to install it manually to every end customer. So what they need basically very efficient distribution and management of applications in various customer tenants, and this is what the Cumulocity can provide very good. So you need that, of course, secure. You need all the management of devices, of connectivity, of users and roles, of dependencies, of tenants. You need that in a scalable manner, and you do not want to do that from the scratch. So as soon as you do have multiple customers, even in multiple regions, for example, it is way too hard and way too complex to do both, basically create solutions that you can sell to your end customers and also keep your IoT platform on the stack. So this is why we are offering the Cumulocity as the basis. So you can basically create your solutions, such as the OEE app, for example, on the basis of the Cumulocity and sell that to the end customers. And we are taking care of the security, scalability of the application of the platform, and you can take care of the application that is beneficial for your end customers. And I want to show you how this can look like. So what I'm basically going to show is I will show you a management tenant. So a tenant then consists of multiple subtenants. So many customers are below this management tenant. So I'm administrating them, and we will check on one customer what applications he is using currently, and also what applications I could give him. And then I will show you how I can give this customer access to the OEE application in this example, such that this will be later on a business case where I can start distributing and developing applications to my customers. So in here, I'm in my management tenant. So I do have multiple subtenants in here. So it's 4 in this example. So I do have here the CNC Dreh- und Fräszentrum in Darmstadt. I do have also a Fahrzeugzentrum and somebody that is producing on batch. And every of these pictures here, or every of these tabs, is basically just one whole subtenant with a whole platform. So if I click on this one, for example, I can see some meta information about the customer. So I see the contact name, whether the tenant is enabled or not, when it's expiring. So especially if I give free trials, for example. But I can also see which applications are subscribed to this tenant. So currently the customer is using, for example, Apana. He's using streaming analytics. He's using SMS sending. But now maybe this customer, Mr. Miller, it's in this example, he's asking me whether he can use the new OEE application. And I tell him, yeah, of course you can. And depending now on my business model, I can just give him the application. And you see it's just basically one subscribe click here in the UI. This can also be automized in the backend such that it's just a REST call in the backend. I can even do that with integration, as you have previously seen, together with other systems or a shop system, for example. And now Mr. Miller is capable of using the OEE application. I can also like unsubscribe the application again. So Mr. Miller is not allowed to use the application anymore. And with this, I have a very good and efficient method to management the distribution of multiple applications to multiple customers. Same is true for new applications that might occur here on my management tenant, or if I start updating the different applications, then the platform takes care here for the distribution for the different tenants. So to sum that up, what you have seen here is the management tenant here as your IoT platform. And we do have various basic tenants, so subtenants here where the different customers are located. And for every customer, I can now decide whether he's allowed to use this application or not, which are your differentiators out in the field or can be. So the OEE application is just one example for that as an application that can be beneficially distributed with customers. But same can be true for other applications that are built up on the stack of the Cumulocity and distributed via the management tenant of your IoT platform. Which brings us now to the end. So we have seen basically 4 chapters today. So the first one started with the calculation of the visualization of the OEE KPIs in a hierarchy. So meaning where are my machines in which sites or lights where they are located, such that I can get a very good and fast overview and even an aggregated overview about the OEE factors or KPIs inside my site area or my machine park. I also showed you how you can, in a non-coding environment, generate a mapping for the OEE KPIs based on different OEE profiles we just created. I showed you how you can benefit from connecting various systems such that OEE KPIs and other IoT or other data is combined. And I showed you how the OEE app and other apps can be the differentiator out in the field and how you can distribute and manage them with various customers. And just to come a little bit back to the OEE application, the OEE app is actually a pretty good example on how fast and how good specialized applications or domain expertise applications can be delivered or developed in a co-innovation or in an innovation by customers itself. So the OEE app itself arose within the context of Adamos together with DMG Mori, Dürr, Engel, and Software AG, of course, together with other customers you can see here down. So here the idea was basically arised in a hackathon where the idea of generating OEE KPIs on a generic basis with this, you have seen the calculation rule editor, and we developed that together and now is available as an overall solution on the Cumulocity that is available for other customers. So how to get started? Basically, this is the end line. So I mean, we do have the possibility to offer something we call quick start. So we do have a predefined and a pre-priced possibility to start kind of a POC, right? So consultants from us work alongside with your teams or your people or people on the end customer side for a very quick implementation. So a few machines are connected, OEE calculations are defined, and the first iterations in learning on the OEE app are done. And this should basically build up the confidence in our solution. So, I mean, we're pretty proud of the OEE app, and we know that it's very powerful and capable of doing what we promise. So we will want to show you that. And it also is a door opener for other use cases and solutions. So, I mean, as soon as OEE KPI data is inside the platform, this can trigger or enable other use cases such as alarming or bringing more insights in comparison with other data from SAP systems, for example. And thus, a quick start is something where you can basically start quick to get the first steps in such an IoT solution, which brings value. And with that, I'm done with my presentation. I will basically open up. Okay, perfect. I will basically open up the Q&A. I already have seen there is a question. Oh, the Q&A is already opened. Okay. So if you do have questions, I should have mentioned that at the beginning, just put it on the chat. Since I was not reading the chat, I'm going to do the Q&A now. So the licenses model for existing customers of the Cumulocity related to licensing. I personally do not understand the question. So I mean, we do have a license model, meaning it depends on which deployment it is. Is it edge or cloud? We also have what type of tenant is it? Is it a basic or an enterprise tenant? A part question, two-part question. Okay, good. I think, I don't know whether it's possible that you talk. Oh, it's not, I see. Okay, I will just answer it that way. Okay, so I mean, we do have this this license model that depends on the deployment. So let's go into the first one. So I mean, there is the deployment, what type of tenant it is, and how much and how frequent devices I do have connected to my platform. So that's the licensing model for the Cumulocity. It depends on various inputs, so meaning what type of devices I do have connected and how frequent they send data. So if you're interested in that, I will guide you through a salesperson that will deep dive into the licensing model a little bit more. And related to the licensing, yeah, I already said that, right? So I mean, it depends on whether it's on edge on cloud, whether it's on cloud on your side or on ours. So those are all informations that go into the pricing and will thus give an indication on how the pricing is set together. Okay. Any other questions to the OEE application, to the Cumulocity platform? So I mean, you can also do that afterwards as well, right? So I mean, if you're interested in a more specialized demo, I mean, this was a very generic demo now. If you want to see more detailed what the OEE application is capable of doing, then just reach out. You will get emails for this webinar anyway, I guess. And then we can come back to you with more detailed presentations or Q&As or even licensing models on how this could look like for your solution. Okay. I will stop the recording, so maybe